Hey everybody, Mr. Kowalik here. Today we're going to do a screencast series on sedimentary rocks. This will probably take a few videos, so stay tuned for all the parts. I like to start out this video with a question. If you look at this rock sample here, what do you see? Now, you're probably saying, well, I see layers, or I see cracks, or I see separation between all these rocks that go in the same direction, parallel lines, something like that. That's exactly what we're looking for. Sedimentary rocks are layered, and we see that, and it's one of our big clues to knowing what a sedimentary rock is. Here's a perfect example of a good sedimentary rock sample. This is a picture of Miss Wells down here. You see here, taking her family to the Grand Canyon on a vacation. And you can see the rock layers that we just saw in the last picture. Each of these layers are a different time in Earth's history. It allows us to go down and down and down and look at this exposed bedrock and look at what happened in Earth's history. Another picture here giving you a better idea of that layering. You can see in the background all these different layers of rocks. There's tans and reds and grays that make up the Grand Canyon walls. So I'm going to ask another question. If 80% of the Earth is covered in water and 80% of the Earth's surface is covered in sedimentary rocks, where do sedimentary rocks form? Right, underwater. Majority of the sedimentary rocks, most all of the sedimentary rocks are forming underwater. And we can see water is a major force in both moving and distributing and creating sedimentary rocks. Another side note about this image is that the Grand Canyon is formed by one thing, and it's right here in the foreground. This is the Colorado River. Moving water formed the entire Grand Canyon. In the last series of videos, we talked about igneous rocks, and we looked at this rock cycle image here, and we saw that magma was one of the first parts in creating the igneous rock. We can also see that most other rocks form into an igneous rock. When we enter into the sedimentary rock part of the cycle, we'll see that sediments form sedimentary rocks, and we'll also see that all three other rock types, igneous, sedimentary, and metamorphic rocks, all form back into sedimentary rocks. You can follow the web all the way around. So the key to remember here is that all rocks can form into each other, and they can take multiple paths, but any rock can become a sediment, and once any rock becomes a sediment, it can turn into a sedimentary rock. There are a few steps in between. We have to get the rock small enough to become a sediment. That process is weathering and erosion. Once they're sediments, they have to be deposited or dropped. Then they need to be buried or compacted and cemented. And in that process of burial, we can assume that they're being compacted and cemented because of the pressures that form them into sedimentary rocks. So let's talk vocab. What is a sediment? The technical term for a sediment is a clast. All right, we're going to see that word pop up a bunch in the next few slides. Clast is a broken piece of a rock, otherwise known as a sediment. Chemical precipitations can also be considered sediments, dissolved solids coming out of a solution. Think of taking a glass of chocolate milk that's freshly mixed up, put it on the counter, and watch the chocolate settle to the bottom over the next 10 or 20 minutes. That settling of a dissolved load produces something at the bottom that's considered a sediment. If you were to evaporate some ocean water and the water leaves, the salts are left behind. Those salts are considered sediments. So we can have it in a couple different ways, but either way, they're considered chemical precipitates, and that's another form of a sediment. We can then take that sediment and turn it into a sedimentary rock. Another way we can form sediments is breaking up things that are organic, such as seashells, or maybe decayed plant matter, which we are going to call coal, and the shells, we're going to call that limestone. We can break that up into pieces, glue it back together, and it's considered a sedimentary rock. In this case, it's going to be bioclastic. No matter what, any rock has to be igneous, metamorphic, or sedimentary by nature. Any rock can be broken down into small pieces. So therefore, any rock can be a sediment. Therefore, any rock can be a sedimentary rock. That process includes weathering and erosion. The rocks need to get small, very small, so they can be glued back together. So we already went over this. Weathering is the breakdown of rock in a natural way, the wearing away of the rock into small pieces, and the erosion of that is moving them into a location where they can become a sedimentary rock. This video here takes a quicker look, a review really of weathering. We can see the video preview right here that they have a rock that's got rained on, maybe frozen, and then cracked open. Again, that's going to be a process of frost wedging, which is your typical physical weathering here for New York. In this video here, if you play it, we're going to see another review of erosion, of materials being carried down a stream and deposited at the mouth of a stream when the stream velocity slows as it enters a larger body, and that sorting process that we talked about back in the weathering unit occurs, and we can turn all of the sorted sediments at the mouth of the river into a sedimentary rock over time. It takes thousands of years.